We begin with the chapter Vector Algebra, which is one of the chapters from your optional part section B. And today we are discussing pretty much the whole chapter because it is easy and it will be concise for us to complete the chapter in one class. Now, to begin with, now all of you have the idea of vectors from your class 11 physics classes, but still let us recap all those ideas once again. To begin with, what is a vector? A vector is a physical quantity which has both magnitude and a direction. And a scalar quantity is, on other hand, is the quantity which has got only magnitude, no direction. Now, geometrically, if you represent a vector, it is always represented by a directed line. Directed line means there is like a ray which has got an initial point and a terminal point. Now, if the initial point and the terminal point are designated as A and B, then the vector is denoted by AB on the top with the arrowhead, which means that A being the initial and B being the terminal or the final point. Then the magnitude of the vector, which is also called the modulus of the vector, is denoted by modulus. Within modulus, you write AB, the vector. And obviously, like any other modulus, for example, modulus of a complex number or any other modulus that we know of, modulus of a vector is also a positive real number. Fine. Obviously, I shouldn't say positive, it should be non-negative because the value of the magnitude can be 0 as well. Then let us move to the types of vector. Now the first and foremost type is basically the zero vector. Now zero vector, as I told you, it is a vector which does not have any magnitude or does not have any direction, and it is represented by 0 and on top an arrowhead. Then we have unit vector. Unit vector is any vector having a magnitude 1, that is called a unit vector. A proper vector, any non-zero vector, that is any vector with non-zero magnitude. So obviously if a vector has non-zero magnitude, then definitely it has got a direction as well. If it is a zero vector, it does not have a magnitude and does not have a direction, but also on other hand it can be said that the direction of a zero vector is undefined because it can have infinite direction as well. So therefore any vector which is having a non-zero magnitude and a proper direction is called a proper vector. Then comes negative of a vector. Negative of a vector means a vector which is having the same magnitude as a given vector but has exactly the opposite direction. Then it is called negative of a vector. Then we have co-initial vectors. Co-initial vector means the vectors which is having two or more vectors having same initial points. So for example, if I draw this, then if this is one vector and this is another vector, then definitely these two vectors are called co-initial vector because they have a common initial point. Next, collinear vectors. Collinear vector means two or more vectors lying on the same line. So that is basically if I have a line something like this, AB, and there is some C here. So therefore this vector AC and this vector CB, they are collinear vector, as well as the vector AB is also collinear. Fine. Then we have coplanar vectors. Coplanar vector means two or more vectors lying on the same plane. So for example, if I am drawing anything on this plane, say this is one vector, this is another vector, this is another vector. So as I am drawing all these vectors on this same plane means the screen of the mobile here, so therefore all these vectors are coplanar vectors because they are lying on the same plane. Now let us move to the next part, that is representation of a vector. Now if the initial point of the vector is given by the point x1, y1, z1 and the terminal point is given by x2, y2, z2, then the AB vector is represented by x2 minus x1 I cap, y2 minus y1 j cap and z2 minus z1 k cap. Now obviously for easier representation, let me just denote x2 minus x1 as A, y2 minus y1 as J and B and z2 minus z1 as C. So A I cap plus B j cap and C k cap, this is how a vector is represented in the space, right? And then this I cap, j cap and k cap, these are the unit vectors along the x, y and z axis respectively, the positive direction of x, y and z axis respectively. And then the modulus or the magnitude of the vector AB is represented by under root a square plus b square plus c square. This is, if you want to tally this with your complex number, then you will see that there is a striking similarity between the concepts. The same way we do it for complex number as well. In case of complex number also, we represent the modulus in this fashion. Now basically in like your future classes, you will see that more complex number is basically vector represented in a different way. Now this modulus or this magnitude does what? It gives us the length of the line segment AB. So basically this I cap, j cap, k cap is giving us the direction of the vector, and the magnitude is actually giving us the distance of the length of the line segment of that particular vector, which is also called line of support. Now if the initial point is origin, that is 0, 0, 0, then the vector is called the position vector of the terminal point. For example, if I draw this, so if let me draw this coordinate axis, this is my x-axis, this is my y-axis, then if I have a point, say this point B, and this is my origin, so if I am drawing this vector from the origin being the terminal initial point and this point B being the terminal point, then this vector is called the position vector, or let me just write PV. PV means position vector of B. Fine. So this vector will be called as the position vector of B, right? So now for example, if I have the vector, if I want to find the position vector of A, that is I am trying to find actually the vector OA, that is O being the initial point, A being the terminal point. And similarly if I want to find the position vector of B, it is basically the OB vector, initial point being O and terminal point being B. Now if we follow this particular definition, then we can see x1, y1, z1, they are all 0. So therefore the values will be x2 minus 0, y2 minus 0 and z2 minus 0. So it becomes x2 I cap, y2 j cap and z2 k cap. And similarly for A, it will be x1 minus 0, y1 minus 0 and z1 minus 0. So it will be x1 I, y1 j and z1 k. Fine. Now to the next part. Components of a vector. Now all these components, that is for a vector ai cap, bj cap and ck cap, this a, b, c, these are called the scalar components of the vector in the different direction, that is x, y and z axis, and they are also called the direction ratios of the vector R. Fine. The unit vector which gives us the sense of direction, always remember that for any vector, whatever is its unit vector, that unit vectors actually give us the sense of direction. So you may ask the question that how to find the direction of a vector. Then always remember, if you find the unit vector of any vector, then that gives you the direction. So basically the unit vector helps us find the direction. So to find the unit vector of any vector, what we need to do, we need to divide the vector by its modulus or magnitude. Then whatever we get, that is the unit vector. And also the unit vector is represented by the same letter with a cap on the top. Fine. Now the scalar components of the unit vector for any vector is called the direction cosines of that vector. Remember, not the direction cosine of the unit vector, but they are called the direction cosine of the vector. Why they are called direction cosine? Because these values are basically the cosine of the angles made by the vector along the x, y and z axis. So how to understand this? If I have say I have this axis, so this is your x axis, this is your y axis and this is your z axis in whichever orientation you draw, and I have this vector be the r vector. Then this r vector is going to make some angle with x, y and z axis. So this angle is let it be alpha, this angle be beta, and this angle be gamma. Now obviously the third angle, the gamma angle, it doesn't seem like it is there, but or rather the angle looks a little bit oblique. Now for the spatial arrangement, you can understand that this third angle is, or this third angle we can't represent by a drawing on a 2D plane. For that you need to have a 3D model to understand, but I hope it is clear to you that how this third angle is coming. Now if this angle alpha, beta, gamma is made by the vector along the positive direction of x, y and z axis, then these values, this particular values, this and this values are basically the cosine of these angles. How? So this is how it happens. So as I said, if alpha, beta, gamma are the angles, then cos alpha is basically a by root over of a square plus b square plus c square, cos beta is b by root over of a square plus b square plus c square, and cos gamma is c by root over of a square plus b square plus c square. Fine. Then let us move to the next part, that is equality of vectors. Now how to say that two vectors are equal? Now remember, vectors are not a quantity which has got only one particular value. It has got two different values. One is the magnitude, the other one is the direction. So therefore, to say that the two vectors are equal, then they have to be equal not only in magnitude but also in direction. So if both are equal, then only we say that the vectors are equal. Fine. And if we have two vectors where the two vectors are equal only in direction but not in magnitude, then we say that the two vectors are either they can be collinear as well, or they can be parallel. They can be collinear or they can be parallel. And if two vectors are collinear or parallel, then one vector can be represented as a scalar multiple of the other. For example, if I take say for example, a vector is taken as 2i cap plus 3j cap minus k cap, and b vector is taken as 4i cap plus 6j cap minus 2k cap, then obviously I can see that B vector is basically twice of the A vector, and therefore I can say that B vector is basically nothing but it is parallel or collinear to A vector. Fine. So that's how we deal with the idea of equality of vectors. Next, operations on vector. Now there are two simple operations. Now the first operation is either addition or subtraction of vector. Now if we add two vectors or subtract two vectors, then what happens? They are added or subtracted component wise. And if we have scalar multiplication, then we have the scalar multiplied with each and every single component of the vector. Now one of the topic which I haven't written here, but let me explain it otherwise, that is what the geometrical representation of addition or subtraction of vectors mean. Now there are two different representation. One is called the triangle law, which I am pretty sure you already know, but still, the triangle law suggests that if I have two vectors in the same sense means in the same orientation. So if this is my vector A and then this is the other vector B, then the vector which joins the initial point of the first vector and the terminal point of the second vector, that is taken in the opposite sense, that vector is basically representing the sum of the vector A and B. So you see, what is the meaning of sense? Sense means the direction. You see, this vector is directed this way, the other vector is directed this way. So it is all in the same sense, that is this anti-clockwise direction. And the third vector, that is this other side, the vector arrow is this side. So that means this vector is taken in the opposite sense. And therefore, this third vector is actually representing the sum of the two vectors. Fine. Now I'm not going into the detailed explanation of how this happens or from where it comes, but this is how it works. Now if I want to show you what is the subtraction, now for the subtraction we are going to apply the same kind of logic. So let's say we have the vectors A and this is our vector B, right? This is A and this is B we have. So the vector which is exactly in the opposite direction having equal magnitude, so this will be your minus V vector. Now obviously, what is the sense here? This is the direction of the vector. A is going this way and B is going the other way. Then the third vector taken in opposite sense, like this side, this vector is actually representing the vector A minus B. Fine. So this is how we represent the vector addition and subtraction. Now there is another way of representing it. The other way of representing it is called the parallelogram law. Parallelogram law. Now parallelogram law is something like this. If the two adjacent side of the parallelogram is represented by two co-initial vectors A and B, that is A and this is B, then the diagonal represents the sum. Now how to understand this? So let me complete the parallelogram. So this is the other side and this is another side. So therefore this diagonal is going to represent the sum. How? You see, if this is A vector, I mean this is B vector, then this is also B vector. Now if you see, if you consider this half of the triangle, then this is following the triangle law. A and B are in the same sense in this direction. Then the diagonal taken in the opposite direction, that is in this sense, then this is representing the sum. Right? I hope the idea is clear. So this is called parallelogram law. Now let us move to problems. Problem number 1. Find the value of xyz if a vector is given xi plus 2j plus zk and b vector is given 2y plus yj plus k, and they are given to be equal. Now remember, if two vectors are equal, they are equal both in magnitude and direction, so that means they are component wise equal. When two vectors are equal in magnitude and direction, that means what? They become component wise equal. So therefore x will become equals to 2, y will also become equals to 2, and z will be equals to 1. Clear? Next, number 2. Number 2, find the unit vector in the direction of a, 2i plus j plus 2k. Now as I told you, remember, to find the unit vector I need to divide the vector by the magnitude. So let me first find the magnitude and then divide it by, or divide it from the vector. So the magnitude here is 2 square plus 1 square plus 2 square, that is 4 plus 1 plus 4, that is 9. So under root 9 is 3, and so therefore the unit vector is 2 by 3 I cap plus 1 by 3 j cap and 2 by 3 k cap. Number 3. Find a unit vector parallel to the sum of a vector equals to 2i plus 4j minus 5k and b vector I plus 2j plus 3k, and it is given by a plus b, that is sum of the components. So 2i plus I, that is 3i, 4j plus 2j, that is 6j, and 4j minus 5k plus 3k, that is minus 2k. So rest of the part is all the same, so we just divide it by the modulus, and upon dividing it by the modulus or magnitude, we have 3 by 7i, 6 by 7j, and minus 2 by 7k. Fine. Number 4. Find the vector in the direction of r given by 5i minus j plus 2k, which has a magnitude 8. Now first we need to find out the unit vector. Now unit vector, that is the vector divided by its magnitude, and that comes out to be 5i minus minus j plus 2k by root 30, and then as this is a unit vector, its magnitude is 1. We all know that any unit vector has got a magnitude 1. So now to get a vector which has got a magnitude 8, all I need to do is just multiply it by 8, that is 8 times the unit vector, and therefore our required vector is 8 by root 30, 5i minus j plus 2k. Fine. Number 5. Find the direction cosines of the vector joining the points a 1 2 minus 3 and b minus 1 minus 2 1 from a to b. So here it is mentioned that a is the initial point and b is the terminal point. So therefore the vector is basically AB vector. Now to find the AB vector, first let me find the position vector of A and B, or I could have done it directly as well, but let me just do everything here so that you can understand. So position vector of A, that is right from the origin, so that is I plus 2j minus 3k. Position vector of B, that is minus I minus 2j plus k, and so therefore the AB vector is going to be position vector of B minus position vector of A, that is minus 2i minus 4j plus 4k. Right? Now I am asked to find the direction cosines. Direction cosines means the components, the scalar components of the unit vector. So let me first find the unit vector, and the unit vector is basically this minus 1 by 3 I minus 2 by 3 j and plus 2 by 3 k. Fine. So therefore the direction cosines will be minus 1 by 3, minus 2 by 3 and 2 by 3. Fine. Next, number 6. Find the position vector of a point R which divides the line segment joining the point P and Q with position vectors this and this in the ratio 2:1 internally. Now this is basically the idea of section formula. Now section formula for vectors is all the same as that of the scalar. So the idea is pretty much something like this. So we have a line segment like this which is represented by, say this is the origin. Now this is the point P, this is the point Q, and this is the OQ vector, this is the OP vector, and this is the vector R which is dividing this line segment joining PQ in the ratio m:n. Now if this would have been scalar, we know what the formula already is. So similarly for vector as well, here the R vector, that is the position vector of R, will be basically m into q vector plus n into p vector divided by m plus n. Right? This is what section formula for vectors look like. The same pattern. If it would have been external, then instead of plus this would have become minus. So let us just put it into the formula. So this is what we have. So R vector is equals to np plus mq by m plus n. Now we already know what is m and n. We already know what is p and q. Put in the formula, calculate, and this is your answer. Fine. Now let us move into the next topic, that is next part of the chapter, and that is dot product. So dot product is basically another operation on vectors, but this is not a basic operation. By the word dot product or scalar product, it means that whenever two vectors are, I shouldn't use the word multiplied, but when we apply this operation on two vectors, it gives me a scalar value, and that is the reason why it is called scalar product. So the dot product of A and B is represented by A dot B, and it is defined by mod A mod B cos theta, and this theta is nothing but the angle between the two vectors A and B, and this angle is measured between 0 and pi, that is from 0 degree to 180 degrees. So we are not taking into consideration any any reflex angle. So for example, if I have two vectors, say this is one vector and this is another vector, they intersect. So I can consider this angle as theta, or I can consider this angle as theta. So I can consider any of this angle as theta, but I am not going to consider this whole angle as theta. So just that we have to understand. Now, as we have this scalar product, as you can see that when this product is defined in such a way that it is giving me a scalar value, only a number. So then if I have the two vectors represented in this form, x1i, y1j and z1k, and similarly x2i, y2j and z2k, then the dot product is given by the formula x1 x2 plus y1 y2 plus z1 z2, which is basically component wise multiplication and then adding them. Now property number 1, if A dot B is 0, that means either A and B, they are separately 0, means it can be that one of the vector is a 0 vector, or they are perpendicular to each other. Why? Because obviously if A dot B becomes 0, then mod A mod B cos theta becomes 0. Now mod A and mod B, they are real numbers, positive real numbers for any two non-zero vectors, so therefore they can't be 0. So therefore the only option is cos theta to be 0, and if cos theta is 0, then theta becomes pi by 2. So therefore the vectors become perpendicular. Next, A dot B is equals to B dot A, so the vector the dot product is commutative. So if it really doesn't matter from which side you are doing the dot product, it is going to give us the same result. Then number 3, A dot B plus C is equals to A dot B plus A dot C. So the dot product is commutative over addition as well as it is commutative over subtraction. Then if a scalar is multiplied to the dot product, you can multiply that scalar to either of the vectors. Then theta, that is the angle between the two vectors, can be found out by this formula, that is cos inverse A dot B by mod A mod B, which is pretty obvious from the definition itself. And finally, projection of B on A, that is B vector when projected on A vector. Now what is the idea? Say this is the vector A and this is the vector B, and if I am projecting B on A, that is I am dropping this perpendicular on A, then the projection is given by this length. This length is called the projection of B vector on A vector. So basically projection of B on A means the length that is given by the perpendicular which we drop from the vector B on vector A, and this value is given by B vector dot A cap. B vector dot A cap means the dot product between the vector B and the unit vector along the direction of A. So that is your projection of the vector B on the vector A. Now here I missed out one key property which I didn't write, but I am mentioning it, so consider this as number 7. Number 7 is A vector dot A vector is basically the square of the magnitude. So A vector dot A vector is basically a square of the magnitude, which is pretty obvious because A dot B is represented by mod A mod B cos theta. Now A dot A, the angle between the same vector is 0, so therefore cos theta is 1. So therefore we are left with mod A into mod A, which is mod A square. And for the same reason, I cap dot I cap is same as j cap dot j cap, and that is same as k cap dot k cap, which is equals to 1. Fine. So these are the 7 different properties of dot product. Now let us move to the problems. So problem number 7, following the chronology. Number 7, if A is given by this and B is given by this, then show that A plus B is perpendicular to A minus B. So let us start. So first let us find what is A plus B, and then let us find A minus B. So do your calculation from now on. I am pretty sure you will be able to do it. I am not explaining much. So once we have found A plus B and A minus B, now let us find the dot product. So to prove that they are perpendicular, if I can show their dot product is 0, then definitely I can say that they are perpendicular. So now let us find the dot product. So 6 into 4, that is 24, 2 into 4, that is minus 8, and minus 8 into 2, that is minus 16. So basically 24 minus 8 minus 16, that is exactly 0. So I have shown that dot product of two non-zero vectors to be 0, and that means the vectors are perpendicular. Fine. Number 8. Find the projection of the vector b plus c on A, and the vectors are given. So remember, projection of b plus c on A means b plus c dot A cap. Now first let us find b plus c. So once we have found b plus c, let me find A cap. A cap is a vector divided by the magnitude, and so we have it here. And after this, then we have to find the dot product. So projection of b plus c on A means b plus c dot A cap, and then you do the product. Once you have done the product, the value is 2. So therefore, the projection of b plus c on A is 2. Fine. Let us move to the next one, number 9. If A and B are given, then find the angle between 2A plus B and A plus 2B. So now I am asked to find the angle between A plus 2B and 2A plus B. So first let me find the vectors. Now for ease, I am denoting the vector A plus 2B by C and vector 2A plus B by D. And we have calculated the vectors. Now, to find the angle theta, so let the angle theta be the angle between the two vectors C and D, which is basically 2A plus B and A plus 2B. So we know the formula. Cos theta is basically C dot D by mod C mod D. And if we do our calculation, the cos theta value comes out to be 31 by 50. And so therefore, the angle is cos inverse 31 by 50, and we can leave our answer to that. We need not calculate any further. We can just leave our answer here, cos inverse 31 by 50, which is going to give us some angle. Whatever the angle be, it is going to be some angle. Number 10. If A, B, C are three vectors such that mod A, or the magnitude of A, is 5, magnitude of B is 12, and magnitude of C is 13, and given that A plus B plus C is 0, then find the value of A dot B plus B dot C plus C dot A. So there are a lot of things given. We need to find the value of this expression. So let us begin. It is given that A plus B plus C is 0. So that means if I take dot product of any vector to this vector, then it will be 0. So therefore, A dot A plus B plus C is also 0. Now let us remove the bracket and calculate. So now A dot A is basically mod A whole square, and then A dot B and A dot C. So from here I can write A dot B plus A dot C as minus 25. Why? Because mod A is given mod A is given 5, so mod A square becomes 25. Taking on the other side, it becomes minus 25. So on the same fashion, I can calculate B dot A plus B plus C and C dot A plus B plus C. So from here, I found these three equations, 1, 2 and 3. Now let me do what? Let me add them up. If we add them up, 1, 2, 3, if we just add them up, what do we get? Twice of A dot B plus B dot C plus C dot A, and that is basically minus 338. Now divided by 2, we get A dot B plus B dot C plus C dot A as minus 169. Fine. So this is how you calculate this kind of problem. So that's it about dot product. So now let us move to the next one, the next topic, that is cross product. Now in case of cross product, or it is also named as vector product, so this is again, it is not exactly by the word product, it really does not mean multiplication, but this is an operation which when applied on two vectors gives me back another vector. So the cross product of A and B is defined by mod A mod B sine theta into n cap, where obviously theta is the angle between the two vectors, but here in this case the theta is represented, the theta angle is between minus pi by 2 and plus pi by 2, and the n cap vector is nothing but it is the unit vector perpendicular to the plane containing A and B. So basically what does A cross B represent? If I have a vector A and if I have a vector B, so this is my A vector and this is my B vector, then n cap or A dot B is actually representing a vector which is perpendicular to the plane containing A and B. So now here on paper it is hard to make you understand, so let us consider that the mobile screen is the plane which contains the vector A and B. Then the vector n cap, that is the unit vector along the direction of A cross B, is basically coming out of the screen. It is just coming out of the screen, perpendicular to the screen. So let us understand it by that way. Now properties. Before we go into properties, I think this is again something which we already know, that the cross product of A and B is defined by the determinant given like this. And then we move to the properties. The first property is, if A cross B is 0, then obviously either A or B, they can be 0, means individually the vectors can be 0, or they are parallel to each other. Why? Because if the cross product is 0, then sine theta becomes 0, and sine theta becomes 0, that means theta becomes 0, and theta becoming 0 means they are parallel to each other. Next, A cross B is basically equals to minus B cross A. So cross product is not commutative as that of dot product. So it really matters from which direction you are doing the cross product. So if you just change the direction, you are going to end up with a different value, precisely the negative of the value. Next, okay, one important thing, I forgot to put an arrow here. I should have put one arrow, because remember A cross B is a vector product, so it gives me a vector. So writing A cross B equals to 0 is meaningless. I should have A cross B is equals to 0 vector. So there should be that vector symbol, which I missed. So please don't miss it. Next, A cross B plus C, again cross product is distributive over addition or subtraction. Cross product is also distributive over scalar multiplication, so it really doesn't matter where you are multiplying the scalar. You can multiply it outside the whole product, or you can multiply it to individual vectors also, no problem. Sine theta, now the angle theta, how to find the angle theta? It can be found by sine inverse modulus of A cross B by mod of A mod B. So it is pretty clear from the given definition. Then number 6, area of parallelogram with adjacent sides A and B. So the modulus of A cross B, it gives me the area of the parallelogram represented by the adjacent sides A and B. Fine. So these are the properties. And also, if you want the area of triangle, half the area of the parallelogram, so half of modulus of A cross B gives me the area of the triangle represented by the adjacent sides A and B. Fair enough. Now again I missed another point which I should have written here, that is number 7. Now A cross A, it is equals to 0 if the same vector is cross producted with itself, then it gives me the vector 0. Why? Because obviously the angle between the same vector is 0, so therefore sine theta will become 0, and hence the cross product will be 0. And for the same reason, I cross I, that is equals to j cross j, and that is equals to k cross k, and that is equals to 0. Fine. right? And then after this, property number 8, I missed this one as well. Now if I have the coordinate axis something like this, where this is my I cap, this is your j cap, and this is your k cap, that is the 3 coordinate axis, then I cross j will be k, j cross k will be I, and k cross I will be j. So this is how we find the cross product of the unit vectors I, j, k. So this is your the triad. We call this the triad, or your left hand right hand thumb rule, if you remember. So this is how it works. Next, let us move to the problems. Number 11. Find mod of a cross b if a is equals to 2i plus j plus 3k and b is equals to 3i plus 5j minus 2k. So you are asked to find the modulus of the cross product. So let us first find the cross product. So cross product is given by the determinant. We are capable of solving the determinant, so let us solve it. And this is your cross product a cross b. And now to find the modulus, just under root, then square and add it. So you get root over of 507. So this is your answer. Number 12. Find unit vector perpendicular to the vectors a given this and this. So perpendicular to the vector a and b, that means what? It should be the a cross b, because we know any vector that is perpendicular to two given vectors is represented by their cross product. So let me first find the cross product the same fashion. So this is what our cross product is. And then to find the unit vector along this direction, I need to divide it by the magnitude. So if I just divide it by the magnitude, so let us first find the magnitude, that is root over of 42. And if I divide it by the magnitude, this is my unit vector perpendicular to A and B. Fine. Now, number 13. The vector minus 2i plus 4j plus 4k and minus 4i minus 2k represent the diagonals BD and AC of the parallelogram ABCD. Find its area. Now, instead of the sides, the diagonals are given. Then how to find the area of a parallelogram? If the sides would have been given, we already know that we just find the modulus or the magnitude of the cross product, then we get the area. But now we are given the diagonals. So how to work with it? Now let us draw this parallelogram and understand. See, if I have the parallelogram like this, then if this is your A vector and this is your B vector, you just see the sense. B vector going in this direction, A vector going in this direction. So this is in this sense. So therefore, the diagonal taken in opposite sense, that is this diagonal taken in opposite sense, gives me the sum of the two diagonals, sum of the two vectors. So this diagonal is represented by A plus B. And again, if I have the vector B on this direction, A on this direction, so therefore on this direction it will be minus A. So therefore the diagonal taken in the other direction gives me B minus A. So therefore, if A vector and B vector are the diagonals, are the sides of the vector parallelogram, then the diagonals are represented by the sum of the sides and the difference of the sides. Fine. So now, if we understand this first, this geometry, if we are clear of this, then let us see how to make use of the diagonals to find the area of the parallelogram. So let us say that d1 is basically a plus b, and let us say d2 is basically a minus b. Now obviously, why I have written a minus b, it really doesn't matter which sense you are taking. If you take in the opposite sense, then it becomes b minus a. So it's all about the sense in which sense you are taking it. Now if I do d1 cross d2, so d1 cross d2 is a plus b cross a minus b. Now we know that cross product is distributive over addition and subtraction, so we can break it. Now a cross a is 0, b cross b is 0, so we are all left with b cross a and a cross b. Now a cross b, if it is flipped on the other side, then it becomes b cross a, positive, and so it gives you twice of b cross a, right? So therefore, if I take the modulus, that is modulus of d1 cross d2, it is twice the modulus of a cross b, which is basically twice the area of the parallelogram. So therefore, area of the parallelogram can be written as half the cross product, or half the magnitude of the cross product of the diagonals. Fine. So this is something we came across. So now let us find the area. So we are already given the diagonals, so let us first find the cross product. So following the same way, the cross product is this. And then let us find the modulus. Modulus is 12 root 5. And so therefore, the area of the parallelogram is half the modulus of the diagonal, or magnitude of the cross product of the diagonal, and that is 6 root 5 square units. Clear? Let us move to number 14. If A is given by this, B is given by this, and C is given by this, find the vector D which is perpendicular to both the vectors A and B, and C dot D is equals to 27. Now perpendicular to both the vectors A and B, that means D vector is parallel to A cross B, right? Now perpendicular to A and B, there is only one vector which we know, that is A cross B. Now D vector is another vector which is perpendicular to A cross B, so I mean A and B, so therefore D vector is parallel to A cross B. So now let us first find what is A cross B. A cross B, following this determinant and solving, so A cross B is something like this: 32i minus j minus 14k. Now we know that if two vectors are parallel, one vector can be represented as scalar multiple of the other. So therefore, the vector D can be considered as some lambda times 32i minus j minus 14k, right? Then it is also told that C dot D is 27. C dot D 27 means this dot product is 27. So now let us do the dot product. So that is 64 plus 1 minus 56 times lambda is equals to 27, or 9 lambda is 27, or lambda is 3. Now let us put back the value of lambda into D, and so the vector D is 96i minus 3j minus 42k. So this completes our chapter vector algebra, that is the first chapter of the two chapters, that is vectors and 3D. Now there was one part of this chapter, scalar triple product, which has been removed from the syllabus, so we are not covering that part, but anyway we will be requiring it in the next chapter, so we will do it there itself. So thank you so much. If you have any doubt, get it clarified.